So they're asking us to find a quadratic equation that passes through, has x-intercept, passes through some points and has some given features. When we're all done, we know we're going to have a quadratic equation in this form. Okay, so the trick is to find out what A, B, and C are. So they're telling us that the other idea, it could be factored out also. I mean, there's nothing wrong with saying that, x, if you know the zeros, and that's what happens with this next one, times x minus k times, that's the same form, and if they aren't being specific in how that they want it expanded out, it's certainly all right to leave it in this form also. Okay, it depends on what we're given. So for 19, they tell us that we have x-intercepts of -3 and 1, so that's why I'm going to use this next form. I'm going to say, well, it's x minus a -3 becomes +3, and then the other 0 is -1, so x minus 1. If you think about solving quadratic equations, that's how you're going to get the -3 and +1. Now the only trick is, how do we get the a? How do we know there's no stretch going on here? So what I'm going to do is I've got this a out in front. So we haven't used this y-intercept of 0, 2 yet. So basically what we're going to find is we're going to find f of 0 with what we know already. So since f of 0 is 2, and we know x is 0, we can take that formula that we created, replace the x's with 0. If it were another number, say 1, we could replace it with 1. It probably wouldn't be 1 since that's a 0, it's one of the zeros, but it could be another number, and now we're just going to solve this for a. So that's going to be a times 3 times -1. I'm sorry, a should be 2, shouldn't it? It won't let me erase that. So basically that gives me 2 equals -3a. So if I divide both sides by -3, that will tell me the stretch factor. So my function for number 19 is -2/3 x plus 3 times x minus 1. And there's certainly perfectly acceptable to leave that function in that form. Again, unless this is a MyOpenMath question where you're going to FOIL it out. Okay, so I hope that helps there. So on just a slightly different feature, like 23, they're telling us the vertex and they're telling us a y-intercept. So since they're telling me a vertex, I could just go ahead and write that in vertex form. Plus k. Alright, so since they're telling me the vertex is 4, 0, I can write in f of x equals some stretch factor times x minus 4 squared plus 0. It doesn't really matter. I don't even really need to have that in there. And then I'm going to make use of the y-intercept. Well, we're basically finding f of 0. So I know when x equals 0, y equals -4, and because it's plus, no shift up or down, I'm going to leave that alone. So that gives me -4 equals a times -4 squared. Well, -4 squared is 16. So -4 equals 16a. We'll divide both sides of this equation by 16. That'll give me a equals -4 over 16, which simplifies to -1/4. And that's my stretch factor. So my final answer can be, let's see if it'll let me erase that a. Oh, it will. I'm just going to insert that -1/4. And that is the function that fits number 23. So I hope that helps. So now we've got one of these word problems, and this is the one like on the exam, so it's probably worth doing for you. Probably it's worth your time watching this. So they're telling me a height function, and it is height, and it's based on time. So they're asking me what time was the rocket launched. Well, when it was launched, that's when t equals 0. So basically we're finding h of 0. So that means I'm going to replace t with 0. And I'm hoping you're seeing that when t is 0, these other terms just kind of cancel out. And what's left is the 234. So that tells me A, the rocket was problem A, tells me it was launched at 234 feet, or meters. Okay. So for part B, it says how high was it ever, so in other words, how high was it? So basically what we're trying to do is find the vertex. I know this is a parabola that opens down, so it's going to have a vertex that's going to be a maximum. And I know it's going to open down because the leading coefficient is negative. Okay, so it's been reflected around the x-axis, if you want to talk about it in terms of reflections. So we're going to find the vertex. We're just going to do the negative b over 2a to find the x-coordinate, and then you're going to substitute that back into the height function. That'll tell us the height. So we'll find two things: when it reaches its height and how high it gets. So for this problem, b is 229, so I'm going to write negative 229 over 2, let's see. Here. To erase that. So over 2 times negative 4.9. Which if we grab our calculator and do this, I'm getting 23.367 seconds is when it reaches the height. So now I'm just going to substitute that in and find out what h of 23.367. And seriously, for me, folks, all you've got to do, if you've done that work, then you can just key that into your calculator. If you have a TI 83 or 84 calculator, an 89, though I've never played with an 89, one thing you can do with it is once you get a calculated answer, and that's where I see it, that's my 23.367, you can just use the second negative key to call up this answer feature, and that's all I did. I substituted that answer in for my t. Okay. And that's how high the rocket reaches in meters, is the 2909 and some in a fractional part. Okay, so that's part B. Assume the rocket will splash down the ocean, and what time does the splashdown occur? Well, that is x-intercept. So I'll do that on the next screen. To find an x-intercept, we want to know where y equals 0, or in other words, h of t. So that's the equation I'm going to write. Is that equation, and then I would just have to solve that for t, and certainly it's a quadratic equation, it's equal to 0. I think using the quadratic formula would be the best bet. So I think I said on the exam, in a college algebra class, when you're learning about the quadratic formula, do the setup. When you get to this level, folks, and as long as your calculus professor is not going to insist that you do this by hand, and very few will still these days. Use technology. Use a quadratic formula solver. There's plenty out there, and that's what I'm going to choose to do here. I mean, I could do the setup, but why? So this is what my calculator. What I did is I wrote a quadratic formula program for my calculator, and I use that. There's many others. The iOS has a nice scientific calculator. If you're interested, I can point you to the link for the app. It's got solvers in it. So those are the two solutions, and of course we aren't interested in the negative solution because we don't want to go back in time. We want to go forward. So that tells us that this rocket splashes down 47.735 seconds after it's launched. Okay. Now the only other thing I am going to ask you on a test or quiz, if you're watching this before you've taken the exam, the first exam here, is the other thing I ask you is how high does a rocket? So to find something like when is this rocket at a certain elevation, and to draw that on a graph, and I'll show you how to do that next. So what I have is I'm interested in when is h of t equal to 500 feet. So the equation I'm going to solve is where's 500 equal to negative 4.9t squared plus 229t plus 234. And then we're going to set this quadratic equation. We're going to set it equal to 0. So negative 4.9t squared plus 229t minus, because I'm subtracting 500, let's see, what is 500 minus 234? 300 and negative 300 and negative 266. I did my arithmetic right. And then go ahead and put that into your calculator. So here's what my calculator told me. So there's 2 times. That would make sense, because if it initially is at 234 feet, that tells me it's going to pass through 500 feet twice, once on the way up, once on the way down. So to make a little sketch of this, all we have to worry about is draw a parabola, draw the line 500, y equals 500, and we know that x is 1.192 seconds, and we know this x is 543 seconds. Okay, to get you used to thinking about things that way. Hope this helps.